Hello, I'm Catherine, and I find it quite remarkable how people that deals with the art of mathematics use variables that we nowadays take for granted. Are we really aware of who was the first mathematician who invented such practical symbols for writing problems that undoubtedly contribute to the evolution of the science of mathematics? Approximately between 210 and 290, in Alexandria, a Greek mathematician named Alexander the Diophantus became widely known as the father of algebra due to his work Arithmetica. He was the first one who established and formalized the third mathematical notation for writing problems. However, little is known about his life. Whatever knowledge we do have stems from the Greek anthology of number games and puzzles created by Metrodorus. One particularly interesting problem looked at the exploring Diophantus age from a puzzle written on his tombstone. By having the variable x representing his life, the problem says, "Passenger in this tomb rests Diophantus. To you who are wise, science will give the measure of his life. Listen. The gods allow him to be young for 1/6 of his life, another 12, and his black bear grow. After another 7, his wedding day came. In the 5th year of his marriage, his son was born. What a pity for the young son. Having lived only half years of his father, he met the frost of death. 4 years later, Diophantus found solace in sorrow by reaching the end of his life. So we can easily conclude that Diophantus lived for 82 years. Diophantus also refers to a collection of entries known as Sporism, a book that unfortunately has been lost. However, we get to know 3 of these entries, all refer to his book Arithmetica. One particularly interesting says that the difference of the cube of 2 rational numbers given a and b, where a is bigger than b, is equal to the sum of 2 other rational numbers, cd. Nowadays, several scientists look at exploring different Diophantine equations. However, most of the problems set in his work led to coedric equations such as ax cubed plus bx equals c, ax cubed equals bx plus c, ax cubed plus c equals bx. For us, all 3 are summarized into the first, since unlike Diophantus, we have predicted the event where any of the variables can be 0 with similar solutions, and moreover, we can deal with negative coefficients, a mathematical situation which he avoided looking at. Without any doubt, we can conclude that Diophantus' work laid the foundations of mathematics as well as made our mathematical thinking much simpler. Remember that there were quite a few great mathematicians, such as Pierre de Fermat, who based their works on his findings. For instance, he proved that for large integer values of n, the equation xn plus yn equals zn has no integer positive solution xyz. A proof that until a decade ago was worth 1 million euros. Thank you for your attention.
Thank you, Catherine. Thank you very much.